All right, one interior angle of a regular polygon is 160 degrees. How many sides does it have? So today we have a quiz, and we're going to give you the formulas. You didn't have to memorize the formulas yet, but you do have to memorize them by Friday because that's when your test is. So there are some key words in this warm-up. One, and interior. There's only one formula that deals with one and interior. And so we grab that formula. Well, you know we're not going to grab that formula. You know there's a better way to do it. But you can grab that formula. N minus 2 times 180 divided by n equals 160 degrees. And you can solve for n. And those of you who are great at algebra and like puzzles like this where you're trying to solve for n, then you can go for it. You can solve for n. But those of you who struggle with isolating n in this problem, I would work in the exterior instead of working in the interior. So for every interior angle, there's an exterior angle that goes with it. And they're always going to form a linear pair, these two angles. So what I would do is convert this from an interior to an exterior angle by subtracting from 180. So the exterior angle is 20 degrees, not 160. So now we've moved from interior to exterior. And the exterior formula for one exterior angle is much easier than the formula for one interior angle. So you convert to exterior and you solve for n. How do you solve for n? You put this over 1 and you cross multiply. 360 times 1 divided by 20. You can flood the chat with your answers now. Go. So is everyone okay with n being 18? It's an 18 gone. It has 18 sides. N always stands for the number of sides. N is 18. Okay. Let's go over the answers to your polygon homework. But then I also want to ask you if you have questions over your first 6 weeks review, because we gave this to you a while ago, and your DPM is tomorrow over this. So before class is over, I need to see if you want me to work any of these. The answers to these are online, where I put all the review answers. That's where the answers to this is. There are 10 problems on here. There'll be 20 problems on your DPM tomorrow, but it is just a quiz grade. Yeah, we gave it to you like 2 weeks ago. So either print out a new one or find where it is. Fractions are your friends. Okay. Next page of answers. Starting with number 3 from the homework. Number 3 says the sum of the measures of the interior angles is given. Find the number of sides. When you read a problem like this, especially on the quiz, you need to highlight key words. I see some key words in there. I see the word sum, and I see interior angles. By the way, if it doesn't say whether it's interior or exterior, it's always interior. If it doesn't say, it's always interior. So there's only one formula that matches sum of the interior angles. There's only one out of the 4 that we learned. So that helps us grab the right formula. The right formula is n minus 2 times 180. Remember where that came from? We were dividing it into triangles, and the number of triangles was always 2 less than the number of sides. So you don't do, if it's a octagon, you don't do 8 times 180, you do 6 times 180. Anyways, so that's the formula for the sum of the interior angles, and we already know the answer. Remember, it's one of those where we're working backwards like Jeopardy. I give you the answer and I want to know the question. So the sum is 7,020, and all we have to do now is solve for n. This one is easier to solve for than the other one that is divided by n. So step 1 would be you divide both sides by 180. You should get 39. And then you do the opposite of minus 2. Now, a lot of people on the quiz will put 37 because they're going to subtract 2. But remember, we're still solving for n, so we need to isolate n, so we need to do the opposite of what's being done to it. So n, the number of sides, is 41 sides. Very good. Okay, next problem, number 19. In quadrilateral ABCD, so we've got a quadrilateral. No one said it was any certain type of quadrilateral. It's not a rectangle, it's not a square, it's not a trapezoid, it's just a quadrilateral. And our angles are in the ratio of 1 to 2 to 3 to 4. When you see that word ratio, because we've had a lot of problems like this lately, you attach an x to each one of those pieces of the ratio. That's how ratios work. You attach an x to them, and then you add them up to what they're supposed to add up to. Now, some of us know that quadrilaterals have 360 degrees. But let's pretend you didn't know that. You can find out how many degrees are in a four-sided figure by using the formula. N minus 2 times 180. 2 times 180. All right. So if you didn't know that a quadrilateral has 360 degrees, then you do the formula. Instead of n, you put 4 because it has 4 sides. All right, so we know the drill. You can tell what's happening here. 1x plus 2x plus 3x plus 4x equals 180. Can you get it from there? Or do you want me to keep going? Not 180, sorry. 360, sorry. 360. 10x equals 360, x is 36, and then to find the measure of each one, you would plug it back in. Now, it did say which segments are parallel, so I do need to keep working this. Sorry about that. So we've got A, B, C, D. When we plug them back in, we get 36, 72, 108, and 144. Which segments are parallel? So remember, if two lines are parallel, then same side interior angles are supplementary. So we're trying to figure out which ones are supplementary. 72 and 108, boom, those are supplementary. So this one is parallel to this one. That's our parallel lines, and that's our transversal. And B and C are same side interior angles. Whew! All right. Last one, 22. Horrible picture, sorry about that. Arc, 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 arc. We have this on one of our other homeworks. You've already seen this before, actually. Okay, step 1, find the missing angles in this triangle right here. 180 minus 100, and then cut it in half, right? So 40, 40. Well, those other two angles have arcs as well. 40, 40. So now in this large triangle, we've got 80, 80, and x. And so you just add 80 plus 80, 160, and subtract it from 180, so 20 degrees. I'm not really teaching you anything new today. The lesson is isosceles and equilateral triangles, but I think you already know all of this. But let's reinforce it and practice a few practice problems. So yeah, isosceles. I will never ask you where the word came from, but I think it's good to know these things. Iso means same, and skelos, don't know how to pronounce that, means leg. So same leg. So it's two sides of the triangle that are the same. Equilateral, equal, obviously. Lateral means of a side or sided, so equal sided. When a triangle is isosceles, this is for an isosceles triangle only, there are certain things that we call the angles and the sides. There's certain vocab. So let's start with, what do you think is behind this rectangle? You can't see what I'm pointing to. This rectangle right here. What's behind this rectangle? What are those called, those two sides with the tick marks? Someone said it. Oh, maybe it doesn't disappear. Oh, there it goes. Legs. So the two sides of an isosceles triangle that are congruent are called the legs. What's the side that's not congruent? What do you call this one down here? The bottom one. Yes, Quan, very good. That is the base. Oh, I just got rid of the base angle. Sorry. There's the base. So we've got the base and we have two legs. And then the angles that surround the base are just what you would guess they are. They are called base angles. And what is that last angle called? Angle number 1. Oh, apex? That's kind of a good guess. Starts with a V, though. Vertex. I'm going to ignore what the other people wrote because that's ridiculous. Vertex angle. Okay, so the angle where the two legs meet, the two sides with the tick marks, where the two sides of the tick marks meet, that's the vertex angle. And then the angles that surround the base are called the base angles. Okay, so from now on I'm going to use these words and expect that you know what I mean when I say legs and base angles and vertex and base. Okay, we have definitely gone over this before, but it wasn't like officially in a lesson. So let's make sure we all agree that this is called the isosceles triangle theorem, and it says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So what you do is you draw an arrow away from the tick marks, and you're pointing to the base angles. You're pointing to the congruent angles. We learned on last week, remember? The largest side is across from the largest angle. Well, if two sides are the same, then those two angles better be the same. So this goes really well with our triangle inequality theorem. The converse is also true. If two angles are the same, then two sides are the same. How do you figure out which sides they are? If you need to, you draw an arrow, or you just visually draw an arrow in your brain, and then you add tick marks to the sides that lie across from the base angles, across from those arcs. It's also true for equilateral triangles. I think y'all totally already know this. If a triangle is equilateral, then it's equiangular. So if it has 3 tick marks, then boom, it has 3 arcs. And not only do we know that those are congruent, we know the exact measure of those angles, right? We don't even have to solve for the angles, because if it's equilateral, those are 60, 60, 60 every time. The converse would be if a triangle is equiangular, then it's equilateral. All right. So if all angles are congruent, then all sides are congruent. Woohoo! All right, now we get into where we're solving some problems, and then we will go over this review and take our quiz. So the key here is to look at the angles across from the tick marks. Look at the angles across from the tick marks. So 22, 22, because those are the base angles. Now we can add those up and subtract from 180. To get x, you can find the linear pair of 136, or you could use our, remember our exterior angle theorem? The remote interior angles add up to the exterior angle. You could do that as well. Or you could just do 180 minus 136. Okay, draw an arrow away from the tick marks, away from the tick marks. 44, 44. And then we would subtract that from 180. 180 minus 88. Oh, that's not drawn to scale. Whoa. And then you could use the exterior angle theorem, or you could just find the linear pair of 144. Back to 136 again. What questions can I answer? Was that okay? Just using our knowledge of congruent sides mean congruent angles. Okay. Didn't see anything. Okay, angle A is x plus y. Angle C is 4x minus y. Solve for x and y. We haven't done this in a while, have we? Where we're solving a system of equations. Sometimes you do, Ganesh, sometimes. If this angle's 90, and these two angles are congruent, then what is the measure of those two angles? What is 180 minus 90 divided by 2? They both 45. Oh my gosh. Okay. They are both 45. So x plus y is 45, but also 4x minus y is 45. This is already beautifully set up for elimination. So we add these together. X plus 4x is 5x. Y minus y cancels. And 90. X equals, thank you, V. X equals 18. And now we need to find y. 18 plus y equals 45. 45 minus 18. No, Edriel. $27. Awesome. Good. How many more do we have? Because I need to give you all a lot of time. Let's do this one and then we will move on. The figure shows isosceles triangle RST adjacent to a regular pentagon. Find the value of x. Isosceles triangle RST adjacent to a regular pentagon. How are we going to find x? This will help you on the quiz because this has a polygon in it. Good. Find one interior angle. Find one interior angle. So 5 minus 2 times 180 divided by 5. Very good. We're using our formulas. So that's 3 times 180 divided by 5. So every angle of this pentagon is 108. How did we get that? We just grabbed the right formula. Okay, now we're going to do linear pair. The linear pair of 108 is 72. So those are the base angles of our isosceles triangle. And then we just add those up and subtract from 180, right? Very good. 36 was the final answer. Good. Okay, before we take our quiz, we're about to start the quiz. What questions do you have over this? Check your answers. Maybe we can go over questions tomorrow right before the DPM. Thank you for asking about number 9. Here's the deal on number 9. I did not teach you how to find, I did not teach you how to do nth term and find things like this. I did not teach you this. So, do you notice how I made number 9 multiple choice and none of the other ones are multiple choice? I made number 9 multiple choice because you have to use your answer choices to solve this one. We didn't really teach you how to solve this one without answer choices. So, what I would do is just either by hand or in your calculator, I would plug in 1 and see if you get 9 out. I would plug in 2 and see if 16 comes out. Try it with A, and if it doesn't work, try it with B, and if it doesn't work, try it with C. So on number 9, and on this one on the DPM, I would assume that you're going to use your answer choices to solve the problem. You're not going to find it without the answer choices. Okay? So, I'm not circling B. It's not, I didn't say B was right. I was just saying I didn't teach you how to do ones like that. So yeah, you just need to plug in 1, and then add 2, and then square it. And then plug in the next one, and so on and so forth. The answer was C. Yep, the answer was C. It's on my key. So you work backwards, you use the answer choices. Is this the only problem that we could plug in? No, the whole DPM will be multiple choice. But I'm just saying this is one where you really have to use the answer choices. None of the other ones would you have to use them, but you totally can use them, yes.